So we're starting a new unit today, Unit 9, and this is going to be about statistics. First of all, if you haven't already done so, make sure you get a copy of the packet from the either from the website or from our Google Classroom page. If you don't have a printer, you can just view the pages on the screen and write your answers to the homework on separate sheets. If you do have a printer, I would suggest printing out the packet. If you don't have a printer and really feel like you need a copy of the packet for this to be successful, please do email me and I'll figure out a way to get you a copy of the packet. This unit's going to be a little different than many of the other units we've looked at so far this year. We're going to take a little break from expressions, equations, and functions. We'll come back to that in our final unit to look at statistics. And there are two specific things we're going to look at. Statistics is all about looking at data from the real world and trying to make sense out of it. And there are two main topics we're going to look at in this unit. The first one is how to collect that data in a good way to make sure that it's good, useful data for us. And the second thing we're going to look at is once we have that data, how can we use it and make some interpretations and all of that. The first two sections, the first 2 days of this unit, are going to look a little bit different, perhaps a little bit more even like an English class than a math class. But just go with me on this and we'll see what happens here. We're going to start looking at section 9.1, which starts on page 3 of the new packets. Selecting and drawing conclusions from samples. And this is all going to be about how to get good data if we're trying to collect some data. First definition, a population. A population is just a group of people or objects that you want information about. A population is a group of people or objects that you want information about. A population is a group of people or objects that you want information about. So, for example, our population could be maybe all the residents of Ashland. We want information about what the people of Ashland think about this whole coronavirus crisis, for example. It's not always practical, though, to ask every single member of a population their thoughts. It's very tough to actually get to all 17,000 or whatever people in Ashland. Plus, if we could, we wouldn't always get a response from them. So we need some way of asking just a smaller group of people that will represent our population. And the smaller group is called our sample. We're going to define this as a subset of the population. It's a smaller group that we hope represents the population. I think these two definitions will make a little more sense with our first two examples that we take a look at. In letter A, we're told that in a recent survey, 3,002 adults in the United States were asked if they read news on the internet at least once a week. 600 of the adults said yes. We're asked to identify the population and the sample. Well, our population is everyone that we're trying to get information about. Well, we asked 3,002 adults in the U.S., but we did that to try to figure out what all of the adults in the U.S. do. That's going to be our population. All the adults in the U.S. Our sample, so it's not practical to ask all of the adults in the U.S. about reading the news on the internet. Instead, we're just going to ask a small group of them and try to figure out things about the entire group based on the smaller group. Our sample is going to be the 3,002 adults who were surveyed. And we do need our language to be very specific here. Not just adults who were surveyed. Which adults? The 3,002 adults who were surveyed. Take a look at the next example and see if you can come up with the population and the sample. The U.S. Department of Energy conducts weekly surveys of 800 gasoline stations in the U.S. to determine the average price per gallon of regular gasoline. On February 10th, 2014, the average price was $3.31 per gallon. We want to identify the population and the sample. See what you can do. My population, all gas stations in the United States. My sample, the 800 particular gas stations that were surveyed. Population, the big group of people that I want information about, but it's not practical to actually ask every single one of them. The sample is the smaller group that is hopefully representative of the bigger group that I can actually do a survey on. Next, we're going to look at 4 different methods of collecting these samples. I'm on page 4 now. 4 different sampling techniques. And I think these techniques will make the most sense if we look at a concrete example. We're going to say that Mrs. St. Kerr is looking into possibly changing the school schedule from 5 periods a day to 7 periods a day and would like to collect student opinions on this. No, she isn't actually thinking about doing this. It just makes for a good example here. She's prepared a short survey, but it's not practical to ask every single student in the school their opinion on this. So we're going to look at a bunch of different ways that she can administer the survey. And we want to see the good things between the various ways, the issues with the various ways. Our first method of creating a sample is called a self-selected sample. In a self-selected sample, members of a population volunteer to be in a sample. Members of a population volunteer to be in a sample. In a self-selected sample, members of a population volunteer to be in a sample. So, for one way for Mrs. St. Kerr to collect a self-selected sample, she could make an announcement about this possible schedule change. She could hang up flyers, and she could send out an email to all the parents stating that any students interested in discussing the topic and providing feedback should go to a meeting Tuesday after school in the main office. At the meeting, she gives the students the survey on changing the schedule. Well, I think there are some issues with trying to get student input this way. Namely, that you are volunteering to be in the group to discuss these things. Usually, only people with very strong opinions are going to show up. So you're going to lose a lot of valuable opinions from students that way. Also, you have to make some effort if you want to be in the samples. In this sample, you have to actually show up to this meeting on Tuesday. Plus, there could be some issues with her choosing the fact that it's going to happen on a Tuesday and after school. It might conflict with some other things. But the idea is a self-selected sample. You are choosing if you want to be in that sample. Not necessarily the best way of collecting data, but one method of collecting data. We'll add a little bit more into this later. The second method of collecting data is called a systematic sample. In a systematic sample, a rule is used to select members of a population. A rule is used to select members of a population. By rule, something like choosing every 5th person or something like that. In a systematic sample, a rule is used to select members of the population, maybe like picking every 5th person. For example, let's say Mrs. St. Kerr prints up a list of all students by ID number. She then selects those students whose ID number ends in a 9. These students will end up completing that anonymous survey. She finds them during the day, gives them a one-question survey to complete anonymously. She has no way of knowing who submitted what response, so that's not really an issue. There's a rule. She looked at all their IDs and just selected the people whose ID ended in a 9. Sometimes there could be an issue with selecting people in this way. More about that a little bit later. But this seems like a better method than just taking anyone who wants to give their opinion and leaving out people whose opinions might not be as strong. This is called a systematic sample, where there's a rule. Page 5. A convenience sample. A convenience sample is where easy-to-reach members of a population are selected. Easy to reach members of a population are selected. In a convenience sample, easy-to-reach members of a population are selected. For example, Mrs. St. Kerr stops by the library during B block. There are 30 students in the library. She asks the students working in the library what their opinions are. She gives them that survey and gets the opinions of those 30 students. Well, there can be all sorts of issues with creating a sample this way. If she's just going to the library during B block, maybe B block is the period that chorus meets. So any students who are in the chorus would not be included in this particular sample. Those students would be what we say underrepresented. Maybe the people who are in that particular B block study hall in the library are just sophomores, juniors, and seniors. Maybe the freshmen don't know about going to the library and don't go to the library. And if that's the case, then the freshmen would be underrepresented here. We want a sample that really represents everyone in the population evenly. Convenience sample would not be a way to do that. But it's an easy way to collect data. Go to something that's already there and ask the people who are already there. One final method is called a simple random sample. In a simple random sample, every member of the population has an equal chance of being selected. Every member of a population has an equal chance of being selected. Everyone has a chance of being selected. People with strong opinions, not as strong opinions. People who are in chorus, not in chorus. People who are in any grade level. Everyone has an equal chance of being selected. The way we can do this with our Mrs. St. Kerr example, she could put every student's name on a slip of paper. She puts them in a box, 800 some names in a box. She then shakes the box and picks out 30 slips of paper. She then calls those students down to the office and gives them the anonymous survey. Every single student had an equal chance of being selected. Not being in B block study hall didn't hinder your chances. Not being able to attend a meeting after school didn't hinder your chances. Everyone has an equal chance of being selected. So the first thing we need to be able to do is we need to be able to look at some scenarios and just determine which of those 4 methods of sampling are being used. I want to do the first example, parts A and B. You'll try the second example. A sports writer wants to survey college baseball coaches about whether they think wood bats should be mandatory throughout college baseball. We want to determine the type of survey, or the type of sample that's being described there. In part A, we're told the sports writer contacts only the coaches that he has cell phone numbers for in order to get quick responses. Well, that would be a convenience sample. It's a group of coaches that are already sort of a group. They're an easy-to-reach group that he already has some information on. We're going to call that a convenience sample. It's a group that's already there. They're already there on his phone. He just has to look at the numbers and call those people that he happens to be closer friends with. Part B. The sports writer mails out surveys to all the coaches and only uses the surveys that are returned. Well, this is an example of a self-selected sample. Self-selected sample. Everyone gets the survey, but only people with particularly strong opinions will return that survey. Self-selected sample. Take a look at the next example and see if you can figure out how we would label those two samples. Manufacturer wants to sample the parts from a production line for defects. We're going to identify the type of sample first. The manufacturer has every 5th item on the production line tested for defects. And B, the manufacturer has the first 50 items tested. I would call letter A a systematic sample, because there's a rule for deciding which things are going to be tested. Letter B would be called a convenience sample. You just went with an easy-to-reach group of objects, just picking up the first 50. Convenience sample. Well, I haven't yet used these two words, but they're very important when we consider creating a sample. And this is the idea of making sure that a sample is unbiased, as opposed to a sample being biased. An unbiased sample is a sample that is truly representative of the population you want information about. A sample that is representative of the population you want information about. An unbiased sample is a sample that's representative of the population you want information about, as opposed to a biased sample. And our definition is going to be that that sample over-represents or under-represents part of a population. I'll explain this better in just a moment. A sample that over-represents or under-represents part of a population. In an unbiased sample, we have a sample that truly represents the population we want information about. In a biased sample, well, that sample over-represents or under-represents part of a population. Going back to the example of Mrs. St. Kerr surveying students, if we're looking at a self-selected sample, that's a biased way of collecting information about people. It's biased because, well, first of all, only those students with strong opinions are showing up if they're going to the meeting. It's also biased because it underrepresents those students who have a conflict Tuesday afternoon. It underrepresents those students who aren't noticing the flyers, or students whose parents don't share information that she sends out in her emails. It's going to be a biased sample. We're going to overrepresent those people with strong opinions. A systematic sample, where there's a rule for selecting people. I think the way that Mrs. St. Kerr did it, where she selected all the students whose ID ended with a 9, seems like a pretty unbiased way of doing it. However, every now and then, a systematic sample could still be biased. We're assuming that ID numbers are truly random numbers, but that 9 at the end could actually represent something. Perhaps that 9 shows up on the ID number of every single student who's a freshman. Well, that would be an issue. The example that I used to do in class was, let's say I want students' opinions on how easy it is to read my writing on the board. And I'm going to go through the room and pick every 4th person to give me their opinion. So I'm going to go 1, 2, 3, 4. 1, 2, 3, 4. Let's pretend this is my seating chart. 1, 2, 3, 4. 1, 2, 3, 4. And let's say I ask the people who got a number 1 to give me their opinion. Well, that would mean I'm only picking those people who end up sitting on the front row, which is not going to be a very representative answer based on what the entire class might think, because they get a different perspective compared to other people in the class. So a systematic sample could still be biased. There could be some hidden pattern included in there. A convenience sample, where you just go with a group that's already there, that's a biased sample. We already talked a little bit about Mrs. St. Kerr going to the library during B block study. Well, that's underrepresenting those students who have a class that is only offered during B block. You won't get any of those students. Might underrepresent students from a particular grade. Might underrepresent those students who feel like they'd be more productive during study hall if they just stay in their classroom. The simple random sample is truly the only way to create an unbiased sample, to make sure we find some way where every single member of the population has an equal chance of being selected. One way of doing that is the way Mrs. St. Kerr did, with all the names on slips of paper, picking them out of a hat. There's another way of doing this that I'll show you in a little bit. I'd like to go to page 7, and we're going to take a look at 2 examples over here. In the first one, we're told the manager of a concert hall wants to know how often people in a particular community attend concerts. He asks 50 people who are standing in line for a rock concert how many concerts per year they attend. We want to figure out if that sample is biased or unbiased. Well, hopefully you would realize this is a convenience sample. He's going with people who are already there. But there's another issue beyond that. It's biased because I think that people who are standing in line for a concert are probably more likely to attend concerts than just anyone in the general population. I'm going to say this is biased because those in line for a concert are more likely to attend concerts. And again, this is an example of convenience sampling. In the next example, a magazine asks its readers to send in their responses to several questions regarding healthy eating. We want to figure out if this is biased or unbiased. This should be biased as well. If you're asked to send a response back, well, only people with really strong opinions are likely to respond. Only those people with strong opinions are likely to respond. And this is a self-selected sample, because you're choosing if you're going to be included in the sample or not. So we want to talk about how to choose a good, unbiased sample that truly is representative of the entire population. Let's say you are a member of the prom committee and you want to poll members of the junior class to find out where they want to hold the prom. There are 180 students in the junior class. We want to describe a method for selecting a random sample of these 40 juniors. Well, one way we could do this is the way we already saw with Mrs. St. Kerr, where she put all the names on a slip of paper and put them in a box and picked out 40 names from a box. But there's another way we can do this using what's called a random number generator. Here's how this is going to work, and then I'm going to show you what this random number generator actually looks like. There are 180 students in the junior class. I'm first going to make a list of all 180 students. I'm then going to assign each a number from 1 to 180. So use the computer, get your list of 180 people, and just assign each a number, 1 through 180. We're then going to use this thing called a random number generator. I'll show how your calculator can be used to do this in just a moment. And we're going to use it to select 40 random numbers. Use a random number generator to select 40 random numbers. If we end up getting the same number twice, we'll just discard it and pick a new number. If a duplicate number is selected, discard it and pick a new number. Once I have those 40 random numbers, I'm just going to choose the 40 students who match up with those 40 numbers. I'm going to use this thing called a random number generator to randomly pick 40 numbers. Once I have those 40 numbers, I'll just choose the students whose numbers correspond to those. Let me show you how you can use your calculator to do this. So I'd like to show you how to use the calculator to generate random numbers. This is not something you need to be able to do, but I figured it would be worth showing you just how this works exactly. I'm going to show it to you on the graphing calculator, but similar thing works on many scientific calculators. First of all, I took all 52 of my Algebra 2 students, and I gave every one of you a number between 1 and 52. Now, on my calculator, on the graphing calculator, I'm going to push the Math button. I'm going to go over to the Probability pull-down, and I'm going to select option 5, Rand Int. If you have a scientific calculator, you can probably get to this by pushing a button labeled PRB for probability, and if you push that, you should find a command, Rand Int. On the graphing calculator, it brings up this little window that asks for the lowest number, the highest number, and how many numbers I'm going to pick. I'm going to say my lowest number is 1, my highest number is 52. I'm just going to pick one number for right now. On the scientific calculator, it will just say rand int, open some parentheses, and then you would give it the two arguments of 1 as the lowest number and 52 as the highest. You wouldn't probably say the third number. But then I'm going to push enter, and it's going to pick a random number between 1 and 52. Picked 4, which means I'm going to ask Maddie English her opinion. And if I do this again, I'm going to ask Matthew Ducharme his opinion. And if I do this again, Olivia Gleason. And again, Robbie Callaghan. And one more time, Jacob Clay. That's all. Using a random number generator is a good way to create a truly unbiased sample, a truly simple random sample. The other way you can do that, or I'm just going to say names in a hat, like the example from Mrs. Sanker. Taking a look at the next page. A computer teacher wants to know if students would like the morning announcements posted on the school website. And he surveys the 20 students in one of his computer classes. Well, we're asked to determine what sort of sample that is. That seems like a convenience sample to me, because he is just asking those students who are already in one of his classes. We want a way to get a good representation of the entire school. I think if you're asking students in a computer class if they might check the school website, perhaps those students would check the school website more often than students not taking a computer class. So what's another method we could generate a random sample of 20 students? Well, we could assign each student in the school a number. And then use a random number generator to select 20 numbers. And then, of course, we'll just pick the students who correspond with those 20 numbers. this is a better way than putting names on slips of paper and stuff, because even with the Mrs. St. Cyr example, she had 800 names on little slips of paper in a box. It would be very easy for her to use the computer and get a quick list of all student names from iPass or whatever. It'd be very easy for her just to number them with 1 or 2 commands in Word, and then she'd have her list rather than having to cut up slips of paper and all that. One more thing that we need to talk about, which is called margin of error. And finally, we're going to get to some numerical calculations today rather than just talking about vocab terms and all of that. Before we define this, I'd like to show you an example of margin of error. Actually, I changed my mind. Let me define margin of error first, then I'll show you an example. Anytime that we are conducting a survey and asking an unbiased sample, even if we choose a good unbiased sample where everyone in the population has an equal chance of getting selected, there's still a limit as to how good that sample is to predict what the entire population thinks. If Mrs. St. Cyr just asks 30 students their opinion and gets some good data from that, there's still going to be a little bit of error between what that sample is telling her versus what the entire population would say if she was able to ask everyone. This idea of error is called the margin of error. We're going to define this as a calculation that shows how much the responses of a population would differ from the responses of an unbiased sample. This is a calculation that shows how the responses of a population might differ from the responses of an unbiased sample. The margin of error is a calculation that shows how the responses of a population might differ from the responses of an unbiased sample. For example, let's say that we survey a couple people and 40% say they prefer candidate A. We're told that our margin of error is plus or minus 4%. I know that in my sample, 40% of the people preferred candidate A, but I can use this margin of error to predict that in my entire population of absolutely everyone that I want information about, what percent of people actually prefer candidate A? Well, it could be as low as 40% minus 4%. It could be as low as 36%. It could be as high as 40% plus 4%. It could go as high as 44%. Anywhere from 36% to 44% of the entire population might prefer candidate A if I know that in my particular sample, 40% said they prefer candidate A, and the margin of error was 4%. Let me show you another example of this. Let me show you a real-world example of this. Back in the end of January, early February, PBS conducted a poll of adults to figure out what they thought about this coronavirus thing, if it was a real threat or if it was blown out of proportion. 66% of adults said it was a real threat, 27% said it was blown out of proportion, 7% said they weren't sure. Keep in mind this was end of January, early February. These numbers would be very different if they ran this poll today. When poll results are given on TV, there's often some information given on the bottom of the screen. First of all, they're saying over here n equals 808. That means 808 people were surveyed. And we're assuming this is an unbiased sample. They're not just asking people from Massachusetts, but getting a good representation of the United States. Next to this, we're told MOE, the margin of error, is plus or minus 4.9 percentage points, basically 5% margin of error, which means 66% of the adults said it was a real threat from the 808 that were surveyed, but from the entire United States, we can generalize that anywhere from 71% down to 61% of the population of the U.S. would think this is actually a threat. Next time you're watching the news and they give some sort of poll results, pay attention to what's on the bottom of the screen where they give the margin of error and see if you can figure out what percent of the actual population would think some particular thing. The margin of error tells us how the information we get from a sample compares to the information that we can assume from a population. And the idea is the more people who are sampled, the better our data is going to be. Our margin of error formula is determined solely based on the number of people who are surveyed. We're going to say if a sample of size n is taken from a large population, the margin of error is approximated by plus or minus 1 over the square root of n. If a sample of size n is taken from a large population, our margin of error can be approximated by using this formula, plus or minus 1 over the square root of n. It's going to give us some sort of decimal, which we can then convert to a percent. Let me show you how to use this. In a survey of 1,011 people, 52% said that television was their main source of news. I want to figure out the margin of error. Well, according to my formula, that's 1 over the square root of 1,011, really plus or minus that thing. Go to your calculator. Let's type this in. 1 over the square root of 1,011 gives me about 0.0315, I'm going to say. That's a decimal. I'm going to change that into a percent by multiplying it by 100. And I'm going to say my margin of error is about 3.15%. Part B, give an interval that's likely to contain the exact percent of all people who use television as their main source of news. Well, in my sample, 52% said that television was their main source of news. I know that can be anywhere from 52 minus 3.15% to 52 plus 3.15%. So, it can be anywhere from 48.85% to 55.15%. The bigger the n, the bigger the number of people you survey, the smaller your margin of error will be, which should make sense. The more people you ask, the better data you're going to collect. One last problem we're going to look at here. A polling company conducts a poll for a U.S. presidential election. How many people did the company survey if the margin of error is plus or minus 5%? Well, I'm just going to work backwards. I know the answer. I know the margin of error. I can set up an equation to solve for this. I'm going to say 1 over the square root of n equals, remember the formula gives the percent as a decimal. So rather than saying 5, I'm going to say 0.05. And I'm going to do some algebra to solve this. I'm going to put this over 1 so I can do some cross multiplying. 0.05 root n equals 1. Divide both sides by 0.05. Going to get root n equals, go to the calculator, do the division. You're just going to get 20 out of that. Square both sides. N is going to equal 400. If you ask 400 people, your margin of error will be plus or minus 5%. I realize this was a longer video than usual, but I think the homework is going to go very fast. A lot of it is just some labeling with some vocab terms, and then a few calculations with this margin of error stuff. More with this language next time, and then after that class, we'll get back into a normal looking math class with numbers and calculations and all of that.